All right, we'll just record what we have. Okay, so is it recording? Okay. So the probability that event E is rolled, and so the actual formula for probability of these simple events is the number in the event that you're looking at divided by the number in the sample space. And this should totally make sense with this question. They get harder, so then you kind of need to think about the formula sometimes. But in this question, it's saying what's the probability that an even number is rolled? Well, half, right? It's an 8-sided die, half of them are even and half are odd. But if we look at the formula, it's 4 divided by 8, which is the same as 1/2 or 0.5. Or you could say 50% chance. So D says, are E and F mutually exclusive and are they complementary? So we talked about this last class. Mutually exclusive. Oops. Means disjoint, which means what? They have nothing in common. E intersection F would be the empty set. So are they disjoint? Mm-hmm. Yeah. They're even numbers and odd. They have nothing in common. So yes, they are mutually exclusive. And are they complementary? Yeah. So E union F is the whole sample space, right? All the even and all the odd. So it is the sample space. So yes, complementary. So those were the two criteria. If they're disjoint and they add up to the whole sample space, then they're complementary. E, determine a probability distribution. Ability distribution. So that's a table, and it basically shows all the possible events and what the probability is. In this one, they'll all be the same, 1 in 8. There's a 1 in 8 chance that you roll a 1. There's a 1 out of 8 chance that you roll a 2, right? But other things, it may not be even. So there's some that are equally likely. That means you have the same chance of rolling a 1 as you do a 3. But in other experiments, it might not be equally likely. So what could that be? If I put balls in if I put my markers in my bag and I had, 5 blue markers and 3 pink, you don't have an equal chance of getting a blue or pink because there's more blue in there. So they wouldn't be equally likely, right?
Do the same as when you have like card questions, so
yeah.
Like a queen or like a 7.
Right, so getting an individual card would be equally likely. You have the same chance of getting that.
So like if you said a queen card, or not a queen, if you just said like a heart or something.
Right, yeah, you can make the criteria so that they're, right, so you have more chance of getting something than the other. Like a face card versus non-face card. Right. Well, there's 12 face cards and the rest are not. So you have more chance of not getting a face card than you do a face card. Right. So the probability distribution for this would be, so we list the events, we'll call them the simple events. So the simple events are like the subsets that just have 1 in it. So 1, 2, 3, all the way up to 8. Hopefully you have a little bit of room underneath here when you get to the 8, my pages. And then the probability of each. 1 out of 8, 1 out of 8, and so on. They're all the same. And they add up to 1. Or 8 out of 8, which is 1. So that's it. That's all they mean by that probability distribution. And then are the simple events equally likely? Yeah. We don't really even need to define that, it's just, are they all equal? You will see some that aren't equally likely later, but, we'll stop there for tonight. It's a good place to stop, and then we'll start with that sheet. So bring that sheet back next class, and we'll start with that sheet.